Today we're going to go back to related rates and look specifically at triangles. Before we start, there are two formulas that we will most likely use. The first of which is the area formula for triangles. Area equals 1/2 base times height. The second is Pythagorean theorem. A squared plus b squared equals c squared, where c is the hypotenuse, or the side opposite the right angle. The notes haven't changed since yesterday, just the shape. So keep in mind different things that we're doing. When we talk about rate of change, those are the dA dt's, dB dt's, etc. Yesterday we had dL or dW dt. If I look down at the first example, okay, we're going to draw a diagram. I try to always draw and orient my pictures the same, where this is A, this would be B, and this would be C. Okay. The two legs are going to be the non-hypotenuse sides. I'm going to call A 21 and B 28. Okay. Key information is that the short leg is decreasing by 3 inches per second. So my dA dt is equal to -3 inches per second. But my longer leg is shrinking, dB dt, as -6 inches per second. Okay. They want to know what is the rate of change of the area. So we're going to start with the area formula, 1/2 base times height. Okay. And then we're going to look at our diagram and say, okay, in this case my base is actually the A value, and my height is going to be the B value. So I substituted from the general formula into what I actually labeled my sides as. Okay? When I go to do my derivative, I need to recognize this as the product rule. And I can group the 1/2 right along with the A. So my dA dt is going to equal the product rule, where I have 1/2 A here, B here. My derivative of B is going to be dB dt, and my derivative of A is going to be 1/2, right, times dA dt. And now I just need to substitute all of my given information in and solve. So my dA dt is going to equal 1/2. A is 21, dB dt is -6, plus B is 28 times 1/2 times dA dt, which is -3. If I put this in my calculator, I find this final answer to be 105 inches squared per second. Please note that this is the change in area. Area is always going to be square units. Moving down to the next example. A right triangle has legs of 21 and 28 whose sides are changing. So I can set up my picture. (21), 28, A, B, and C. The shorter leg is decreasing by 8 inches per second. The longer leg is shrinking at 4 inches per second. What is the rate of change of the hypotenuse? So when we talk about legs and the hypotenuse in a right triangle, automatically Pythagorean theorem should come to mind. Okay? So over here I'm going to do my A squared plus B squared equals C squared. And if we model from the previous problem, didn't we take the derivative and then plug in all of our values? Okay? So if I do that, I get 2A dA dt plus 2B dB dt is equal to 2c dc dt. That gives me 1, 2, 3, 4, 5, 6 things that I need to substitute in, but if I refer back to my drawing, I only have 4. I need to get one more. And the one more that I'm able to actually get is going to be the length of c. How can I get that? Well, I can get that by using the Pythagorean theorem. A squared plus b squared equals c squared. My a is 21, my b is 28 squared, and my c squared I don't know, so I can solve for c squared and then back solve for c. Quick calculation tells me this is 1225 is equal to c squared, square root of both sides. C is equal to 35. So this is actually going to be the hypotenuse length of 35. Now I can come in and I have 6 unknowns, but now I have 5 of the 6 after this quick side calculation. So I'm going to say 2 times 21 times negative 8 plus 2 times 28 times negative 4 is equal to 2 times 35 times dc dt. dc dt is notation for the rate of change of the hypotenuse. Okay. Now, this is the same thing as 70, so I could divide both sides by 70 to clear it. And if I put all this in my calculator, simplify it, etc., I get negative 8 inches per second as my change in hypotenuse. All right, last example, example 3. So the first couple of problems that we've given you, especially in Delta Math, are fairly repetitive. They're to teach you the process, reinforce the algebra, and have it be the same thing over and over. Eventually, you're going to get to word problems where the information is presented differently, but they will resort back to basic shapes like rectangles or triangles involving perimeter, area, Pythagorean theorem. This is an example of that. So let's break it down and draw a diagram. A ladder is leaning against a vertical wall. So here's my diagram coming out. And then just tilt this for 1 second and say, okay, here's my ladder, and this is going to be my wall right here. Okay, there's my wall. All right, it is a 25-foot ladder. So this is not a collapsible ladder. This is a stationary ladder that is 25 feet in length. The base of the ladder begins to slide away. So what's happening is the ladder is coming out and this is dropping down. It's doing so, the rate of change of this base distance, okay, it's sliding away from the wall. So if I call this A, I call this B and C to stay consistent with my labeling, my dA dt is equal to positive 0.5 feet per second. At what rate is the top of the ladder? Okay, remember the ladder is sliding in this direction. When the base is 7 feet, so the base is 7 feet away, they want to know what is this rate. Okay, so now I look at my diagram and I say to myself, does it make sense for me to use an area formula when we're relating two legs and the hypotenuse in a triangle? No. Ultimately, they want to know at what rate is this moving down the wall. So I'm actually, my BDB dt is what I'm trying to find. I don't know that. Here's what's interesting compared to the previous problems. What about dc dt? Isn't dc dt equal to 0? Does the ladder change its length as it slides down, or does it stay the same? If the ladder stays the same, that's like saying it's a constant. The derivative of a constant, or rate of change, is equal to 0. Therefore, we can say this. Just like the last problem, okay, we had to come over here and set up our Pythagorean theorem. We then had to take our 2a dA dt plus 2b dB dt equals 2c dC dt. And recognize once again we have 6 unknowns. In this problem I have 1, 2, 3, 4. I need one more. So again, I'm going to have to back solve to find the length of b in the moment that the 25-foot ladder is 7 feet from the wall. So let's do a quick subcalculation. Let's plug in everything we know. We're going to solve for b is equal to 25 squared. B squared is going to equal 576. Square root of both sides. B is equal to 24. Now I've set myself up to have 5 of the 6 unknowns in this derivative on the right-hand side. So I can go ahead and fill all of these in. 2 times 7, which is a, times 0.5, plus 2 times 24, times x, is equal to 2 times 25 times 0. 48x is equal to 7. My unknown rate, okay, remember x was dB dt, is equal to negative 0.15 feet per second. Examples 1 and 2 will help you with the Delta Math assignment that is attached to this PDF. However, you should think through the process for example 3 in order to attempt the other 2 word problems. The other 2 word problems are what you would typically have seen on a test when assessing related rates. Any questions, please post in the homework helper.